Okay, ma? So this is the given circuit. Okay. So there are 3 capacitors, 6 microfarads, 6 microfarads, and one more capacitor is also 6 microfarads. Clear? So what is the charge which is present on each capacitor? That is the first question. Then equivalent capacitance and what is the energy stored in the network of capacitors? That is the question. Clear, number? So first of all, let us calculate equivalent capacitance. So equivalent capacitance. So can you say equivalent capacitance will be how much, ma? So first of all, can you say which capacitors are in series and which capacitors are in parallel? What about these two capacitors? Are they connected in series or are they connected in parallel? This one and this one. These are not connected in parallel. These two capacitors are in series. Clear, Nama? These two capacitors are in series. Next, to these capacitors, this one is in series or in parallel? This one is in parallel. Clear, Nama? See, you just see the distribution of charges. If you see the distribution of charges, then you can understand whether they are connected in series or in parallel. So the total charge which is produced here, it gets divided into 2 branches. This is Q1 and this is Q2. Are you able to understand, ma? So same charge of Q1 enters into this capacitor also. So definitely these two capacitors, they are connected in series connection. And next to these two capacitors, this one is connected in parallel. Clear, no, ma? So therefore, what about equivalent capacitance of these two capacitors? So it is equals to C1, C2 divided by C1 plus C2. Clear, no, ma? So 6 into 6 by 6 plus 6. So how much? 6 into 6 divided by 12. So therefore 6 1s are 6 2s are, so 3 microfarads. Clear, number? So equivalent capacitance of these two is 3. And 3 and 6 they are connected in parallel. So therefore total equivalent capacitance is how much? C1 plus C2 as they are connected in parallel. So 3 plus 6 is equals to 9 microfarads. This is the total equivalent capacitance. Okay, ma? So this is the answer for first question. Clear? So then we are going for first question. What is the first question? Charge on each capacitor. Charge on each capacitor. Okay, ma? So how can I calculate the charge on each capacitor? So Q is equals to C into V, no? Q is equals to C into V. Now if I take this branch, what is the capacitance of this branch? Capacitance of this branch is 6. And can you say what is the potential difference across this capacitor, ma? I am talking about this capacitor. About this capacitor, capacitance is 6. Potential difference is how much? Come on. 12 volts only. What is the reason? Because this 6 microfarads capacitor is in parallel connection to this combination. It means that here if I consider potential is 12 volts and here if I consider potential is 0, clear, number? Then same potential is existing here also, same potential is existing here also. Are you able to understand? So therefore, what is the potential difference between this 6 microfarad capacitor? Potential difference is 12 volts. Are you able to understand, ma? So therefore, Q is equals to C into V. Capacitance is 6 microfarad. Potential difference is 12. So 12 6 are 72 microcoulombs of charge will be present in which capacitor? In this capacitor. Clear, no, ma? Similarly, now can you say what is the total charge present in this branch? Okay, ma? Which branch I am saying? I am saying about this branch. About this total branch, what will be the what you call total charge present in that series branch, in the branch in which consists of this is 6 and 6. Can you see? Can you see, ma? What is the total? How I can calculate? Very simple. What is the total equivalent capacitance of this branch? 6 and 6 they are connected in series, no? So total equivalent capacitance is how much? 6 and 6 if they are connected in a series, total equivalent capacitance already we have calculated, no? 3 microfarads. Clear? So about this total branch, capacitance is 3. Now about this total branch, what will be the potential difference? See, ma, this is total circuit. I can redraw like this also, no? How I can redraw this one? This is one battery which is having a potential difference of 12 volts. Instead of 6 and 6, what I can write? Instead of 6 and 6, I can write only one capacitor which is having a capacitance of 3 microfarads. And here I have one more capacitor which is having a capacitance of 6 microfarads. I can draw like this, no? Clear, no? Now what is the potential difference across this 3 microfarads capacitor which is a combination of these two capacitors? Can you see? What is the potential drop about this one? Come on, potential difference is again 12 only, no? 12 only. So here if potential is 12, here if potential is 0, same potential exists here also and same potential exists here also. Clear, Nama? So therefore, we have potential difference of 12 and capacitance as 3. So therefore, again, what is the charge? So this is a Q1. Q2 amount of charge is how much? Again, it is C into V. Capacitance is 3 microfarads. Potential difference is 12 volts. Clear, Nama? So 12 3s are 36 microcoulombs of charge will be present. Clear? Now, this 36 microcoulombs of charge, is it present on 6 microfarads or this one or this one? Can you see? Total charge in this branch we have calculated. Total charge in this branch, that is in this branch is how much? That we have calculated, which is equal to 36 microcoulombs. Now, this is the charge present on which capacitor? This one or this one? Can you see? Both of them is correct. Okay, ma? How can you say both of them is correct? Okay, ma. So therefore, in this branch, total charge which is present is 36 microcoulombs, no? So this 36 microcoulombs is present in which capacitor? This capacitor or this capacitor? Yes, already somebody said the answer. Same charge will be present in both the capacitors. Why? Because both capacitors are connected in series connection, no? Both these capacitors are connected in which connection? They are connected in series connection. If they are connected in series connection, so every capacitor will have same amount of charge. That's what we have studied, no? So therefore, this 36 microcoulombs, it will be present in this capacitor as well as this capacitor. Okay. Now, can you say battery is supplying total how much charge? Battery is supplying total how much amount of charge? Can you see? How much charge? In this capacitance, what is the charge which is stored? Where we have calculated 72 microcoulombs. Similarly, what is the charge which is present in second branch? It is 36 microcoulombs. So what is the total charge? 72 plus 36. 108 microcoulombs of charge is produced by this battery. Are you able to understand, all of you? So this total amount of charge which is produced, some of the charge is entering into this branch, some of the charge is entering into this branch. So what is the charge which has entered here? Same charge will be induced on second capacitor also, which is connected in series. Clear, Nama? So therefore, total amount of charge which is produced by the battery is 72 plus 36, 108 microcoulombs of charge. Clear, ma? So this is our answer for first question. Next, what about third question? Energy stored in this total circuit is how much? Energy stored in this total circuit is how much, ma? Energy stored formula is what? Energy stored, you can use any of the relation, half CV square, okay, ma? Q square divided by 2C, half QV, any value you can use. Clear? So therefore, energy stored is half into, what is the total equivalent capacitance? Total equivalent capacitance is 9 microfarads. So 9 microfarads multiplied by, what is the potential difference which is supplied, ma? 12 square. Clear? So therefore, half into 9 into 144. Clear, ma? 144 means what? 72 into 9. Clear, ma? Into micro means 10 power minus 6. Okay. So just to do this calculation, that should be our answer. Okay. So the final answer which you should get is 6.48 into 10 power minus 4 joules. So 6.48 into 10 power minus 4 joules. Okay. So this will be the total amount of energy stored in this system. That is our answer. Okay. Any doubt in this one, ma? So can you say, ma? So see. So first what he is saying, two identical capacitors of 12 picofarads are connected in series. So therefore this is one capacitor, this is one capacitor. So 12 into 10 power minus 12 coulombs, sorry, farads. So this is also 12 into 10 power minus 12 farads. Clear, Nama? So they are connected in series across a battery of 50 volts. So this is the battery of capacitance, potential difference 50 volts. So how much electrostatic energy is stored in the combination? Clear now? So electrostatic energy formula is what? Half CV square or Q square by 2C or half into QV. Clear now? So equivalent capacitance is how much initially? So because they are connected in a series, so 12 into 12 by 12 plus 12. So answer will be 6. So therefore, what is the total energy stored? Total energy stored will be half into equivalent capacitance is 6 into 10 power minus 12 multiplied by potential is 50 square. Clear ma? So this is the amount of energy stored. So if I do this calculation, what is the answer I will get? 75 into 10 power minus 10. 75 into 10 power minus 10 joules of energy. This much amount of energy is stored in this combination. Clear? Similarly, he is also asking to calculate a charge drawn in each case. So what is the charge drawn in each case? So Q is equals to C into V, that's all. Equivalent capacitance is how much? Equivalent capacitance is 6 into 10 power minus 12. And what is the potential difference? Potential difference is 50. Clear number? So 5 6 are 30. So 30 into 10 power 30, one more 0 is also there, no? So 300. So 300 into 10 power minus 12. Clear ma? So if I do this calculation, 3 into 10 power minus 10 coulombs of charge. So this much amount of charge is drawn in the first case. Clear? Then he is asking second question. What is the second question he is asking? So if these are connected in parallel across the same battery, so it means this is the second connection, no? So this one and both of them, they are connected to the same battery of, so this is a 12 into 10 power minus 6. This is also 12 into 10 power minus 6. This is 50 volts battery. Clear now? Now if they are connected in a parallel, what is the total equivalent capacitance? It is just C1 plus C2. Clear now? So therefore 12, 24 into 10 power minus 6 coulombs of charge is, microfarads of capacitance is present. 10 power minus 12, no, this one, sorry. 10 power minus 12. This is also 10 power minus 12. Clear? So 10 power minus 12 farads of charge capacitance is present. So therefore, what is the amount of energy stored? Energy stored is again half of CV square. So half into 24 into 10 power minus 12 multiplied by potential difference is 50 square. Clear ma? So if you calculate this value, then what is the energy you will get? 3 into 10 power minus 8 joules. So it is equal to 3 into 10 power minus 8 joules. Clear ma? So this much amount of energy is drawn in the second condition. Clear? Now can you say which energy is greater? Energy, is it greater in first condition or energy is it greater in second condition? Can you say ma? Energy stored in first condition is how much? 75 into 10 power minus 10. Clear? Energy stored in second condition is how much? 3 into 10 power minus 8 joules. So energy stored in which condition is greater? Come on, first one or second one? Energy stored in which condition is greater, first one or second one? Second one, definitely here energy stored is greater, no? So this is only 3 into 10 power minus 10, but it is 3 into 10 power minus 8 joules. Clear? Nearly 100 times more energy is stored in this condition. Similarly, he is asking charge stored also, no? Charge which is obtained from this battery. So again, Q is equals to C into V. So capacitance is how much? Capacitance is 24 into 10 power minus 12 multiplied by potential difference is 50. So calculate this one. That is the total amount of charge which is stored in second condition. Clear number? Answer for this one is 1.2 into 10 power minus 9 coulombs. So 1.2 into 10 power minus 9 coulombs of charge is stored. Clear? Similarly, you compare the charge stored in first condition, charge stored in second condition. Charge stored in first condition is only 3 into 10 power minus 10. But here charge stored is 1.2 into 10 power minus 9. So definitely this value is greater when compared to this value. Clear ma? That's it. Make a note of this one. Anybody? Can you say the answer ma? Okay, ma? So this is the given question. So two parallel plates separated by 2 mm of air. So initially distance between the plates is 2 mm, 2 millimeters. So I have a capacitance of, so initial capacitance is how much? It is equal to 3, let us call this one as C1. So 3 into 10 power minus 14. 3 into 10 power minus 14 farads of capacitance is the initial capacitance. And what is the potential difference between them? And they are charged to a potential difference of 200 volts. Clear, ma? So if this much amount of capacitance is present and this is the potential difference, then can't I calculate how much amount of a charge is stored in this one? How much amount of charge will be stored, ma? So initial charge Q is equals to C into V. That's all, no? So capacitance is how much? It is 3 into 10 power minus 14. Clear? Multiplied by potential difference is 200. So therefore 3 2s are 6 into 10 power minus 12 coulombs of charge. Clear? So this is the amount of charge which is present initially. Now what we are doing, then without touching the plates, they are moved apart by 6 mm. So initially this was the capacitor. The distance between the plates was how much? Distance between the plates was 2 millimeters. Now what we have done, we have increased the separation between these two plates. Clear, ma? If we have increased the separation to 6 mm, then these are the questions which we are supposed to answer. Clear? So potential difference between the plates is how much? Change in energy is how much? Okay? Okay. See, now the question is, initially this much amount of a charge was present. Now after separating them to 6 mm, will there be any difference in charge stored or not? That is the question. Okay. So initially these plates, they were having how much a charge? So this positive plate was having a charge of 6 into 10 power minus 12 coulomb. Negative plate was having a charge of minus 6 into 10 power minus 12 coulomb. Now when you separate them to 6 mm instead of 2 mm, will there be any difference in charge stored or not? That is the question. Initially this much amount of charge was present, you know. After separation, how much amount of charge will be present? Can you see? So less than 3 into 10 power minus 12 or greater than 6 into 10 power minus 12? Come on. We are not touching the plates. If we touch the plates, what will happen? Charge may enter into my body and that charge may enter into ground. But I am moving that one without touching the plates. Therefore, charge on these plates is not going to reduce, or charge on these plates is not going to increase also. Clear, ma? Because the total charge is always conserved, no? That is the property of charge. Total charge will be always conserved. So therefore, what we write here, after separation, charge on capacitor does not change. Clear, ma? Charge on capacitor is never going to change. If you are connecting this one in a circuit, then it is a different condition. But this capacitor, it is not connected in circuit, no? So it is just a capacitor which is charged to this particular potential and it has this much of capacitance. Then this is the amount of charge which is present. Then even if you separate that also, total charge stored on that one is not going to change. Clear, ma? But if you separate that, then what is going to change? Charge stored, it has not changed. Then which parameter will change? Can you say? Anybody? If I increase the separation between the plates, which parameter is going to change? You should answer, you should not be silent. Can you say, anybody? Anybody, ma? If I increase the separation between the plates, which parameter is going to change? Distance. Definitely distance has increased. I am able to see that one, no? This is 2 mm, this is 6 mm. What is one more parameter which will change? One more parameter which will change is capacitance will change. Capacitance will change. Clear, ma? Why capacitance will change? Because capacitance depends on what? 1 minute. Okay, ma? Because capacitance is going to change in this. Yes, capacitance will change. Why capacitance will change? Because for a parallel plate capacitor, what is the equation of capacitance, ma? So E naught A divided by D. This is the equation of capacitance. So E naught, epsilon naught, it depends on the medium. Medium is here only, no? So as long as medium is changing, this E value is not going to change. Epsilon naught is not going to change. Area of the plates is also not changing, no? Area of the plates is also not changing. Only distance between the plates is changing. So therefore, if epsilon naught and area, if they are constant, then how can I write a relation between capacitance and distance? I can write C is inversely proportional to distance. C is inversely proportional to distance. So therefore, how can I write C2 divided by C1 is equals to D1 divided by D2. So therefore, C2 is how much? C1 into D1 divided by D2. I can write like this number. So initial capacitance is how much? Initial capacitance is 3 into 10 power minus 14. 3 into 10 power minus 14. And initial distance is how much? Initial distance is 2. Final distance is how much? Final distance is 6. So therefore 2 1s are 2 3s are 1 1 gets cancelled. So C2 is equals to 1 into 10 power minus 14 farads of charge. Clear number? So final capacitance is how much? 1 into 10 power minus 14 farads of capacitance is present finally if we are increasing the distance from 2 mm to 6 mm. Clear number? So capacitance is going to change in this condition. Now just to calculate what are the answers. Potential difference between the plates. First question. So how can I calculate a potential difference, ma? Potential difference V is equals to Q divided by C. So charge stored is not going to change, no? What is the initial charge? 6 into 10 power minus 12. Final charge also will be same only. Now final capacitance is how much? Final capacitance is 1 into 10 power minus 14. So V is equals to 6 into 10 power 2. Clear number? So 600 volts of potential difference is present in this condition. Clear? So therefore, second one. Second one is how much? Change in energy. Change in energy. How can you calculate a change in energy, ma? So final energy minus initial energy. Final energy is how much? Half C2 V2 square minus half C1 V1 square. Clear number? So all these values already we have calculated, no? So just to substitute their values, that should be our answer. Okay, that's all. Okay, ma? So what is the change in energy which you should get? Change in energy which you should get is 12 into 10 power minus 10 joules. Clear, ma? So 12 into 10 power minus 12 joules. So that will be 10 power minus 10. So that should be the change in energy. Clear, ma? Now here one thing is important to discuss for us. See, ma, initial potential was how much? Initial potential is 200 volts. But when you have separated the distance to 6 mm, potential difference between the capacitor plates has become 600 volts. Can you say what is the reason? Logically, how can you explain this one? Already we have studied this one previously. So when plates were separated by 2 mm, then potential difference between the plates was 200. Now we have increased the separation, no? We have increased the separation by to 6 mm. Then the new potential difference is 600 volts. What is the difference? Why potential difference has increased? Can you explain, anybody? Anybody, ma? Can you say, anybody, why potential difference has increased when separation between the plates of the capacitor has increased? Already we have discussed this one, no, ma? So if this is a single what you call plate, and if it is having only positive charges, then this will be having a bigger potential. But if you place another plate which is having a negative charge, clear, no, ma? Then because of this negative charge, it will give some negative potential on this plate. So because of this one, so for example, if I say this is 10 volts, so this is on this plate it is having minus 8 volts. Clear, no? Or on this plate, let us say it is also having minus 10 volts. But what is the effect of this negative plate, potential due to negative plate on this one? So initially they are separated by this much of distance. So because of this negative plate, here I will have a potential of minus 2 volts. Clear, no? Then what is the total potential? 10 minus 2 is equal to 8 volts. So therefore, total potential has become only 8 volts. Now this one, if I bring again a bit closer, then what will happen? Negative potential also increases, no, because potential depends on distance. So V is equals to Q divided by 4 pi E naught into R. So potential is inversely proportional to distance. Clear, Nama? So if distance decreases, then potential increases. So instead of -2, it will become -6 volts. Clear, Nama? So a negative potential of -6 is applied by this negative plate on the positive plate. Clear, Nama? Now what is the total equivalent potential? 10 minus 6 is equals to only 4 volts. So this already we have studied, Nama. So if distance decreases, what happens to potential? Potential also decreases. Clear, Nama? If distance between the plates increases, then potential difference between the plates also increases. But what is the condition? Condition is total charge should not change. All these calculations we are doing only when charge is remaining constant. Clear? Come on, make a note of this one. So you can make a note of this one. What is the note point here we have to write? If charge remains the same, if charge remains same. In which condition charge remains the same? When we are not connecting this one in a circuit. Clear, ma? If a charge remains the same, then if distance between plates decreases, clear, ma? Then potential difference between plates also decreases. Clear, ma? So this is the point which we should understand. Okay, ma? Anybody, can you say how can I solve this question? So a parallel plate capacitor has a capacitance of C. Okay, ma? If the charges of the plates are Q and -3Q. Okay, ma? So if I consider this is my initial plate and if this is my second plate, so what is the total charge present on this one? Q, and total charge present on this one is -3Q amount of charge. Then first question is like this: what is the charges which are present at inner surfaces? Okay, so already we have done this type of problems, Nama. So charges which are present on outer surfaces, charges on outer surface, how we have calculated? Do you remember, ma? So total charge divided by 2. This is what we have done now. So Q plus of -3Q divided by 2. So how much it is? So -2Q divided by 2 is -Q. So what is meant by -Q, ma? So on the outer surfaces, here also I have -Q amount of charge. Here also I have -Q amount of charge. Clear? So, but what is the total charge which is present on first plate? Total charge which is present on first plate is +Q. Clear, Nama? But here I have -Q. So therefore, what will be the charge which is present on the inner surface? It should be +2Q. Because +2Q and -Q, it will be equal to Q. Clear? If on the inner surface, here if I have a charge of +2Q, then what is the charge present on inner surface of second plate? So here it should be -2Q. Clear, Nama? Because the faces which are facing each other, the surfaces which are facing each other, they should have same charge. So if this is +2Q, this should be -2Q. Now see the conservation of charge here. 2Q minus Q. So -2Q minus QQ minus 3Q. Satisfied, no? So therefore, +2Q and -2Q. So these should be the charges which are present on the inner surface. That is our answer for first question. So first question is completed, no? Clear, no? Then he is asking second one. What is the second one? Potential difference between the plates is how much? How can I calculate this one? Potential difference V is equals to Q divided by C. That's all, Nama? Okay. Now Q means which Q I have to take, can you see? Here, potential difference, we know V is equal to Q by C. Q means which Q we have to take. Shall I take this Q, or this Q, or this Q? Which Q I have to take? Can you see? Come on. Charge means which charge I have to take? Here charges means the charges which are present on inside surfaces. Only we are concerned about those charges. Clear? Because energy is stored because of electric field only because of this positive and negative charges. So energy is stored only because of existence of electric field, and that electric field is because of this plus 2q and minus 2q. So charge means the charge which is present on inner surfaces. That is the charge. So therefore V is equal to Q by C. Q is how much? 2Q divided by capacitance is C. So this is the amount of potential difference between the plates. Clear ma? Third question. So what is the third question he is asking? How much a charge will flow if plates are connected? What is meant by plates are connected? If these two plates are connected like this, then can you say what will happen? If these two plates are connected by a conducting wire, then what will happen? So plus 2q and minus 2q, they will get cancelled with each other. So this is what is going to happen. So charge flowing will be how much? So plus 2q charge will be flowing from one plate to another plate. That is the meaning of this one. Clear, Nama? So therefore, how can I write? Plus 2q charge flows from first plate to second plate. First plate to second plate. This is what is going to happen. Clear, Nama? Or I can also say that minus 2q charge will flow from negative plate to positive plate because they are connected by conducting wire, Nama. So this plate is at a higher potential, this plate is at a lower potential. The plate which is having positive charges, it is also considered to be at higher potential. The plate which is having negative charges, it is always considered to be at lesser potential. So charge always flows from positive charge. Positive charge always flows from higher potential to lower potential. Or we can say a negative charge always flows from negative potential to or lower potential to higher potential. So whatever it may be, charges will flow and total charges will become zero on both surfaces of the inner surface. Clear? Okay. So next, which is the fourth question he is asking. Fourth question is energy lost by the capacitor. Clear, Nama? So capacitor will store energy in which form? Capacitor stores energy in the form of electric field. Clear, Nama? And that electric field is present because of what? Electric field is present only because of this plus 2q and minus 2q. Clear, Nama? But if they are connected by conducting wire, then this plus 2q and minus 2q, they have lost their individuality. Clear, Nama? They have lost their presence of charges. So electric field also will become zero. Clear? If electric field will become zero, it means capacitor has lost the charge. So therefore energy lost is how much? Energy lost is equal to nothing but initial energy. Clear, ma? Energy lost is nothing but initial energy. So initial energy is how much? Initial energy is q square divided by 2c. Q I know, so q square divided by 2c. Clear, ma? What was the initial charge? 2q whole square divided by 2c. That's all, ma? So initial charge which was present on each plate was how much? Here plus 2q, here minus 2q. Are you able to understand? Okay. Okay, ma? So energy lost is nothing but initial energy, that's all. So therefore 2q whole square divided by 2c. So 4q square divided by 2c. So 2q square divided by c. So this is the amount of energy lost if both these plates they are connected by a conducting wire. Clear, Nama? So then he is asking charge flown if any one plate is earthed. Clear? Let us see. So charge flown if any one of the plate is earthed. So consider this is my first plate, this is my second plate. Clear, ma? So let us consider I will earth this first plate. If I earth this first plate, what will happen? Total charge which is present on this side, it will flow through the ground. Whether it is positive charge, whether it is negative charge, total charge will enter into ground. Are you able to understand, ma? Why? Because earth is a very big sphere. No, already we have studied this one. Earth is a very big sphere. So its potential is considered to be zero. So whatever charged body, if you connect that one to earth, its potential also becomes zero. Clear, ma? So here what is meant by potential becoming zero? Whatever charge is present on this outer surface, it will enter into the ground. Clear, na, ma? Okay. But this second plate, it is not earthed, no? What is the total charge which is present on second plate? Total charge which is present on second plate is minus 3q. Clear, na? So that total minus 3q, it will be deposited here. And here minus 3q will induce an equal and opposite charge which is equal to plus 3q. Clear, na? So here how much amount of charge will be present? Plus 3q amount of charge will be present. Clear, ma? But on the outer surface of first plate, Here there will not be any charge. What is the reason? Because total charge has entered into ground, because potential of earth is almost considered to be 0. Clear ma? Similarly, if I take a second plate, this is the second plate, this is the second condition, and now I am earthing second plate now. I am earthing second plate. Then what will happen? If there is any charge present on this side, so total charge will enter into ground. But first plate is not earthed now here. So what is the charge present on first plate? Plus Q amount of charge is present on first plate. So this total plus Q, it will be deposited on one side. Clear nama? And this total plus Q will attract a charge of, or it will induce a charge of minus Q on the inner surface of the second plate. Clear ma? So this is what will happen if I earth these plates. Clear? That's all. This is how we can solve this question. Make a note up to here. So this is the given question ma. See here. So two spheres of radii r and 2r. So this is a sphere of radius 2r. This is a sphere of radius r. So they are having charges q and q by 2 are connected with a cell of EMF V volts. Are you able to understand? So initially they were having this much charge. These are the initial charges. So bigger sphere is having a charge of q by 2. Smaller sphere is having a charge of q. And their respective radiuses are 2r and r. So now they are connected by a battery of potential difference V. Now here I have a switch also. So when I close this switch, then you are supposed to find out what will be the final charge on each sphere. Clear nama? So this is the question. Can you say how can I calculate? Okay ma? How can I do this calculation? Anybody? So try to say ma, how can I do this calculation? Okay. Okay. See ma, if I am connecting this one by a battery, then what do you understand from this one? I am connecting both of them with a battery. Then what do you understand? Then we understand that this side of the component it is at a greater potential, this side it is at a lesser potential, no? Clear ma? When compared to this point, so let here potential is V1 and here let potential is V2. Clear? Then what is the difference between V1 minus V2? Can you see? What is the difference between V1 minus V2? V1 minus V2 is nothing but V, because positive plate is always at a higher potential, negative plate is always at a lower potential. So if you see the potential difference between V1 and V2, that is nothing but V here. Are you able to understand ma? So here who is giving the potential difference? Here potential is given by this bigger sphere. Clear ma? And on this side potential is given by the smaller sphere. So if you take the difference of those two, then V1 minus V2 is equal to V. Clear? So now can you say what is the potential due to sphere? V is equals to Q divided by C. That is the equation for potential difference, no ma? So for a sphere or for any charged body which is holding charge, potential is given by V is equals to Q divided by C. Clear? So therefore let us see what we can do. Clear, no ma? So he said that final distribution of charges, if I have connected this battery, charges will be rearranged. Why charges will be rearranged? Because this side there should be a potential difference of V greater when compared to potential present on this side. Clear? So therefore he gave the final distribution of charges, no? So initial charge on this sphere, it was Q by 2. And to this Q by 2, a small amount of Q has been added, whose value we don't know. Clear, no ma? Then if it is getting Q amount of charge, it means this is losing Q amount of charge, no? So final charge. So final charge on second sphere is how much? Q minus Q. Okay. Now already we know that the equation of potential difference V is equals to Q divided by C. Now try to apply in this relation. So potential of this bigger sphere is how much? V is equals to Q divided by C. So therefore I can write Q. Final charge present is how much ma? Final charge is present Q by 2 plus Q divided by C. What is the equation for capacitance of a charged conductor? V is equals to Q by C. Q we have written. Charge present on, final charge present on bigger sphere is how much? Q by 2 plus Q. Now what is the equation for capacitance of a charged conductor? Already we have studied, no? it is equals to 4 pi E naught into r. Radius of this one is how much? Radius of this one is 2r. Clear ma? So minus. Now what is the equation for potential due to smaller sphere? Potential due to smaller sphere is again q by c. Now what is the charge present on smaller sphere? Q minus q divided by, and what is the equation for capacitance? Equation for capacitance is 4 pi E naught into r. Clear number? So we are subtracting the potentials of both spheres. Then what will be the potential difference? Potential difference is V, because we have connected this one to a battery, no? So potential of this side and potential of this side, if you subtract them, then you should get the potential difference of V. Clear? Now here what are the unknown quantities which we have? 4 pi E naught, 4 pi E naught get cancelled. All values are known quantities except this q value, which has been transferred from one sphere to another sphere. Clear number? So calculate this q value first of all, then we can calculate the final charge. So final charge present on first sphere is how much? Q by 2 plus q. Final charge present on second sphere is how much? Q minus q. So just to calculate this q value, substitute in this relation and this relation, that will be the final amount of charge. Okay, come on. Calculate q value and see what is the answer you will get. Okay, so this is the amount of charge which is transferred from one sphere to another sphere. Okay, now just substitute in this values. So what is the final charge which is present on first sphere? Final charge which is present on first sphere is, so q final is equals to q by 2 plus q. So q by 2 plus charge transferred is how much? Q by 2. So q amount of charge is present on first sphere finally. Clear? Similarly, what is the charge present on second sphere? So q final on second sphere is equals to q minus q. So q minus q value is q by 2. Clear number? So it is again equal to q by 2. So these are the initial charges and final charges. Are you able to understand ma? Come on, that's all very simple.